So remember, when it comes to multiplying monomials, right, so we have like a monomial like a to the 7th times a to the 4th, okay? What does a to the 7th times a to the 4th equal?
A to the 11th.
A to the 11th, right? And Jordan, how'd you get that?
You basically add the 7 and the 4.
Right, you add the exponents, right? A to the 7th times a to the 4th. And the idea behind that, right, is if I have, and you don't have to write this all out here, but I will. If I have a to the 7th, right, that's 7 a's multiplied together. And then if I have a to the 4th, that's 4 a's multiplied together. And so if I multiply together 7 a's and 4 a's, well, now I'm multiplying together a total of 11 a's, so that gives us that a to the 11th there. Okay, that's the idea. All right? So, well, now let's say if I take a to the 7th, right, and if I divide by a to the 4th, okay, what does that equal?
A to the 3rd.
Yeah, it's a to the 3rd. That's right. So, yes, the idea is you subtract. And, of course, we can't just subtract in any old order we want. We're going to subtract the top power, okay, minus the bottom power. So 7 minus 4 gives you that positive 3. And the reason for that is, if you can imagine, if I rewrite this, a to the 7th is, 7 a's multiplied together over 4 a's multiplied together, okay? Well, when you have all these a's in the numerator and all these a's in the denominator, what can we do with some of these a's? We can simplify by canceling them out, right? So, for example, this 1a can cancel out with that 1a, this a can cancel out with that a, this a can cancel out with that a, this a can cancel out with that a, and what are we left with? 3 a's in the numerator, right? So there's where we get that a cubed in the numerator, right? Because there's 3 a's left over once you cancel out. So you can see the shortcut we can use is just subtracting the exponents, but the real reason is because they cancel out like that. So, yes, we can have negative exponents. So let's look at an example that involves that. Okay? So let's say we've got a to the 5th, b times b to the 8th, all over, okay, a times b to the 13th. Okay? So, all right, we're going to divide these, all right, and we're going to divide just like we multiply, right? I mean, yeah, the a to the 5th is being divided by b to the 13th, but they're not really like terms, so we don't really worry about dividing those things. But the a to the 5th and the a, they are like terms, right? We're going to divide those. And so what will our new exponent for a be? A to the 4th? Why isn't a to the 5th, though? There's no number written here.
Because it's 1.
It's assumed to be a 1, right? When you have a variable by itself, you've got a 1 there, okay? So maybe it's helpful to even write that in for yourself. And yeah, so a to the 5th divided by a to the 1 is a to the 4th.
Or maybe
And then what's our exponent for b going to be? Yeah, negative 5. Remember, we've got 8 on top, 13 on the bottom, and so we're going to end up with 8 minus 13. We get b to the negative 5.
Couldn't you put maybe the b to the 5th for the denominator?
Right, exactly. So this is not a complete answer yet, because typically we don't want to have, we don't stop believing, right? We don't stop with negative exponents. So we have a little bit more work to do. Okay? So when you have a negative exponent in your answer there, we need to rewrite this so we have a positive exponent. Okay? What's that? Oh, okay, gotcha, that's fine. You can take your whole book out there or whatever if you want. Okay? B to the negative 5th is the same as what?
For b to the 5th over the denominator?
So, yeah, this is the same thing as saying a to the 4th times 1 over b to the positive 5. Okay? B to the negative 5 is the same thing as saying 1 over b to the positive 5. And so now we can rewrite this as a to the 4th over b to the 5th. And that is our final answer there. Okay? So why is b to the negative fifth the same thing as 1 over b to the fifth? Right? That's weird. We're taking a negative exponent, right, b to a negative exponent, and then it becomes 1 over b to the same number but a positive exponent there. What makes that happen? Well,
b to the fifth is inside the denominator in the problem when you cross it out.
Right. So yeah, one way you can think about it here is that if we have 8 b's in the numerator, so I'm actually going to write this out. You don't need to, but I will do it for you. 1, 2, 3, 4, 1, 2, 3, 4. And if we have 13 b's, and yes, I'm going to do this. 6, 7, 8, 9, 10, 11, 12, 13, okay? If we have 8 in the numerator and then 13 in the denominator, we'll cancel them out like normal. Okay, and you'll notice we have no more b's in the numerator, so what number is going to be left in the numerator? 1. Just a 1, right? And then we have b to the fifth in the denominator. And so that's kind of another indication here that, you know, even though, so doing just the cancellation method, we're left with b to the fifth in the denominator, but if we do the subtraction method, right, 8 minus 13, we're left with a negative 5. So it seems like they should be the same thing, right, because they're kind of talking about the same quantity there. So b to the negative 5 is the same thing as 1 over b to the fifth. Okay? And one other way you can kind of see this too, for example, if we have, I don't want to do it that way. If we have like a cubed, okay, right, that's equal to a times a times a, right? If we have a squared, that's equal to a times a. If we have a, that's equal to just a. That's a to the 1, sorry. If we have a to the 0, what does it make sense that a to the 0 should be here? 1. Okay, yeah, if you look here, a times a is a cubed, right? We lower the power by 1, a squared, and now we have 2 a's. So it's like we divided an a away, right? And then we had a to the 1, that's, again, lowering the power by 1, and it looks like we did what again? We divided another a away, right? We had a times a, divide away an a, you're left with just a, okay? Then from a to the 1 down to a to the 0, again, subtracting 1, well, if we divided a to get from here to here, if we divided a to get from here to here, would it make sense to divide from a to get from here to here? So a divided by a is 1. And then that makes sense even if we go down to the a to the negative 1. Again, we divided by a. We divided by a. We divided by a. So we're going to divide this by a. 1 divided by a is 1 over a. So it makes sense that a to the negative 1 is the same thing as 1 over a to the 1, right? And we talk about a to the negative 2. Dividing by a again, yet again, right, makes 1 over a squared. Okay? So you can see the negative exponent is equal to 1 over a to that positive exponent.
What is the last thing, a negative 1?
A negative 2 equals 1 over a squared. Okay? But that's the idea. Okay? All right, let's take a look at a few more examples here. All right, so let's try 7 squared over 7 to the 8th. 7 squared over 7 to the 8th. And let's see here. Let's go to Quanier. So Quanier, what do you say? This will be, can you see it okay? Yeah. Okay.
Well, I wrote it down.
You wrote it down. Okay, good. Okay. So 7 squared divided by 7 to the 8th. What would that simplify to? 7 to the negative 6, exactly right. Or we could write that as 1 over 7 to the positive 6, okay? And so we could, though, right, so we could just type the thing into our calculator. We could say 7 squared divided by 7 to the 8th, and we get this nasty decimal, right? Let's check that. Let's see if 7 to the negative 6 is the same thing, though. Looks the same to me. Right, let's try 1 over 7 to the 6th. And again, it looks the same. See, all 3 numbers are the same there. So they're all equivalent. Okay. So yeah, you could, but the decimal is kind of funky there. So we'll just leave it as that. Okay. So again, try not to leave negative exponents. Try to rewrite things in terms of positive exponents here. All right.
So whenever they do the negative like that, you should just switch it to positive. Yep. So if you have a, yes, that's basically it.
right, x squared y to the 12th over x to the 8th, y to the 7th. Excuse me. Okay. Let's pick someone here. Sorry, Jordan, I'm going to pick someone. All right, let's go to Corey. Don't I do this? All right, I'm going to help you. All right, so here we go. I always pick you, that's right. Oh, I don't always pick you. The calculator picks who it picks, but your number's up. Okay, so we have x squared divided by x to the 8th, right? So what do you want to do with your exponents there? Don't know how to do it, okay? All right, Corey, I won't make you do it then. You need to pay attention. I'll make sure you learn how to do it, okay? Ask questions if you're unsure. Jason, sorry, what are we going to do here to simplify this?
All right, so you're going to do 2 minus 8, which equals x negative 6.
Okay, so x to the negative 6. We subtract the exponents there, Corey. 2, take away 8, so x to the negative 6, okay?
12 minus 7, so equals
Y to the 5, there you go. Okay, so all we did there, Corey, is we had our same base, right? So the x and the x, same bases. We subtract the exponents when we divide them. So 2 minus 8 gives you the negative 6. Okay? Y and y, same base. So we subtract their exponents. When we divide, and you get 5. Okay? Jason, are we done here? Is this our final answer?
No, you're going to put 1 into the x to the 6.
Right, so we're going to make that 1 over x to the 6 times y to the 5th. So instead of x to the negative 6, we can rewrite that as 1 over x to the positive 6. And then, go ahead. Yeah, there you go. And then we can put the y to the 5th in the numerator and the x to the 6th in the denominator, and that's our final answer right there. Okie dokie. Excuse me.
Why would we do that?
I'm sorry, why would we do what?
Why would we put the y in?
Y to the 5th in the numerator? Why does it go in the numerator? Good question. So this is a fraction, right? 1 over x to the 6th. Okay? Y to the 5th is not really written as a fraction, but if we wanted to write y to the 5th as a fraction, we would write it as y to the 5th over 1, right? So this is already a fraction, 1 over x to the 6th. Y to the 5th, if you want to write that as a fraction, you put it y to the 5th over 1, right? We can make anything a fraction, just put it by putting it over 1. Like if I give you the number 3, 3 as a fraction is 3 over 1. So y to the 5th, that's like a whole number. It's not a fraction, but you can make it a fraction by putting it just over 1. And so this is the same thing as saying like that. The y to the 5th is the same thing as y to the 5th over 1. That's what it is. That's how you can write it as a fraction. Is that you? Yes? No?
I kind of, yeah.
That's how you can write a fraction. You can make any number a fraction, just put it over 1. Right? So y to the 5th is a number. I know it's y to the 5th, but it's still, we treat it like a number, put it over 1. Okay? And then when you multiply fractions, what do? Well, when you multiply fractions, you multiply across the top, so 1 times y to the 5th, and you multiply across the bottom, x to the 6th times 1, x to the 6th. Okay? Is that clear? Yes?
Yeah, the only thing is, it says that it's just x with y always at the top.
Well, in this case, because the x had a negative exponent, it's going to go into the denominator as of a fraction. Y to the 5th was a positive exponent, so it stays in the numerator.
Okay.
Does that make more sense now? Okay, thank you for being patient. Okay. Let's try another one. Okay. Okay. What? Y? No, these are P's and Q's. We had Y's earlier. All right, number this next one here, okay? 10p q to the negative 7 over negative 5 p to the 6 q to the 3rd. Okay, these are Q's. I try to put little tails on them. I'm sorry. P's and Q's look so similar. So what's that? So good question. What's the matter, Kwanye? Q is the best letter? Because Q is for Kwanye. Okay.
I would say something, but
Okay, so there's our situation here, right? There's our problem. We want to simplify this.
Can I guess how to do it?
Okay, so 10 divided by negative 5. Let's see, Mr. Whitmire, you told us that we had to subtract here, so 10 minus negative 5, the answer here should be 15, right?
No.
What should I do here?
Divide.
Divide. So we should get what?
-2.
Negative 2. That's right. Okay, good. Whew. I was testing you and you passed. Good job. Okay? These are just numbers. We're dividing them. So you divide those numbers like you normally would. 10 divided by negative 5 is still negative 2. Okay? Now let's look at our exponents, though. So we've got P. What's the exponent for P here? 1. Okay? So we're going to divide. That means what do we do with our exponents?
Subtract it.
Subtract. So, yeah, bless you. So 1 take away 6 is what? Negative 5. So we're going to have P to the negative 5.
2p.
Okay. Yeah, and then, careful, negative 7, subtract 3.
-10.
Negative 10. Negative 10, okay? Because you had negative 7 already up here, divided by the q to the third, which makes that subtract 3. So it's negative 7 minus 3 gives you negative 10 there. Okay. What's your question, Alex? Shh. Why is it negative? Why is it p to negative 5? Because, so think about it this way, right? When we divide, right, p to the 1 divided by p to the 6, right? That's what we're dividing there. Those two go together. We subtract our exponents, and it's always top minus the bottom. So 1 minus 6, negative 5. Right? Isn't 1 take away 6, negative 5? Yeah, so we're left with p to the negative 5. Right. We have to be careful with that. Yes, exactly right. These are coefficients. This is division. When you divide your numbers like you normally would. Here, though, this is not 1 divided by 6. It's p to the 1 divided by p to the 6. So those are exponents now. When you divide numbers with exponents, you subtract the exponents to simplify. Okay, so we have to differentiate those two things. These are numbers. 10 divided by negative 5, right? 10 divided by negative 5 is negative 2. No problem. But here, p to the 1 divided by p to the 6, remember what that's saying, what that's really saying is, I'm going to zoom out just a skosh here, p to the 1 is p, over p to the 6 is 6 p's multiplied together, right? And so then 1 p in the top cancels out with 1 of the p's in the bottom, and we're left with 5 p's in the denominator, so this is really 1 over p to the 5th. Which is what p to the negative 5 is, right? It's 1 over p to the positive 5.
Did you distribute?
Did I distribute what?
How did you get to negative 10?
Well, so q to the negative 7 divided by q to the 3. What do you do with your exponents? You subtract them. Negative 7, take away 3, negative 10.
I forgot what thing.
Right. Well, what else? Go ahead, Alex. Do you have another question?
I know this is 5, and 9 is 5, so that's what makes it less.
But do you see the order of subtraction? It's 1 minus 6. 1 minus 6. So 1 minus 6 is negative 5 for your answer. Thank you.
And then the negative
And then negative 7 minus 3 is negative 10. Right? I mean, here, I'll show it to you. Negative 10, right? You're at negative 7, you take away 3 more, you're now at negative 10. Yeah. You're subtracting a positive 3. So again. Okay, but all that discussion, we are not done yet though, right? Okay, because we have negative exponents. So where are these going to go?
To the denominator.
Into the denominator. So we're going to have negative 2 over p to the positive 5, q to the positive 10.
2p, not 2p.
And there's the final answer. Okay, there's the final answer. Okay.
Bring me another.
All right. Well, we'll get to some here in a second. Yeah. So again, coefficients divide. P, right? You subtract the powers, so we get negative 5. Q's, subtract the powers, you get negative 10. And because we have negative exponents, both of those move into the denominator. P to the 5th, Q to the 10th. Okay, P to the positive 5, Q to the positive 10. Okay. Last thing here, one more, and it's going to be a super simple one.
Super simple.
Okay. X to the 7th divided by x to the 7th. Okay. So again, here, what do we do? We're dividing, so what do we do with our exponents?
We simplify by pressing.
Yeah, we simplify by just, well, we subtract them, right? So what's 7 minus 7? 0. So it's going to be x to the 0.
And which is 1.
Which is 1, right? Anything to the 0 power except for 0 is 1. Okay, so the answer there is 1. Which makes sense, they cancel out, right? All the x's in the numerator will cancel out all the x's in the denominator, we're left with just a 1 at the end. Okay? Alright, questions on any of that?
No. Can we turn our warm-ups?
Yes, I would collect your ones.